Okay, hey guys, we are going to practice now some graphing of inequalities just to see what we can do to learn how to graph them. So we are actually going to skip this one right here, this 914, this what did the boy tree say to the girl tree? We're going to skip that one because honestly I gave you two different copies of the same practice, and this one I think is the one that I want you guys to do, the next page. And maybe we'll go back and do some practice on the other one. But can you find the one called Why Did the Plum Divorce the Grape? It says 913 at the bottom of it. So the idea of this says graph each inequality. And then we are going to learn how to shade this and really see what the graphing of the inequality means and then be able to answer some questions about it down here. So I chose this one first right now because these are all in pretty close to y equals mx plus b. So these are going to be fast for us to be able to graph and see what they look like, and then maybe we'll try some that are in standard form. But this is an inequality, right, that has two different variables. What we were doing before on the last one was ones where it just had one variable, and we just needed to know how to solve one variable inequalities. This is two variables so that we can graph them. So if we have this, y is greater than or equal to 2/3 x plus 1. Let's pretend that was an equal sign for a minute and just graph this. Let's start at the y-intercept. We'd go up 1, put a dot there. Slope, rise over run, 2/3, up 2, right 3, up 2, right 3. I can't do that anymore, but I could go backwards, down 2, left 3 to continue that line, right? If that were an equal sign, I would just connect these dots and I would be done. But this one is a greater than or equal to sign. That means it could be equal to this line. So I'm going to go ahead and I am going to connect those dots and I'm going to make that line. It means the solution could be this line, or the solution for y could be greater than that line. So what are all the y values that are greater than this line? Think about our y values here. Y values up and down would be anything that is above it if the y value could be greater. So what we do is we do this and we shade in everything that is above that line. That would be our solution set for this. So is a solution to this equation 0, 1? Yes, because that is greater than or equal to this line right here. Is a solution to this -2, 3? If I put in -2 for x and 3 for y, yeah, it would be true. Anything that is in this area would be true. If I put in, like this guy, 2, -3, though, we would put that in there and it would not be a true statement. It would not be a solution that makes this inequality true. So that's how we graph inequalities with two variables. When we're doing this worksheet, this is how you're going to check and see if you're graphing this correct. It says, under each grid are true or false statements describing locations of solutions. Circle the number letters next to each true statement. So does this solution, does it include the boundary line? That boundary line means what the actual line that we graphed. Does it include that? Could it be equal to that? Yes, it could be equal to that. Are there solutions in quadrant 1? Do you guys remember your quadrants? Might need to label this up here. Quadrant 1 is up here with Roman numerals. Then it goes left. It goes counterclockwise. 2, 3, and then 4. So you need to know your quadrants. Are there solutions in 1? Yes. Solutions in 2? Yes. Solutions in 3? Yep. There's a little teeny bit of 3, sure. But then all the rest of this part of 3. Are there any solutions in quadrant 4? Will there ever be? No. So we can circle yes, 1, yes, 2, yes, 3, no 4. I'm going to cross that out because that's not a possibility. All right, so later on down at the bottom, you'll be able to fill in, okay, if I circled 19A, I'd go find 19 and I would put in A all the way down at the bottom here. And up there I circled, what, 2H? So I'd go to 2 and I'd put an H down at the bottom. You get the idea. Anything you circle, you're going to fill in down there, and hopefully you're going to actually get an answer at the end if you graph these correctly. All right, I'm going to do one more with you. I'm actually going to do number 4 right now with you. Let's look at number 4. This one says y is less than x minus 2. So let's pretend it's y equals x minus 2. Let's just graph this. X minus 2, the y-intercept is a -2, and my slope is just 1. 1 over 1. So I'm going to go up 1 over 1, up 1 right, okay, and then I could go down and left 1. There's my slope of 1. Now before I connect this, the equation, or the inequality, says that y is less than that. It doesn't say y is less than or equal to, meaning it can't actually be any of these points on the line. It has to be less than that line. And with our y's up and down, less than would mean everything below that line. So below that line would be all of these things down here. And the way that we indicate that it couldn't actually be these points here is we do a dotted line through there, showing that that's our boundary line, but it can't actually be those. So when we're circling our possibilities here, does it include the boundary line? No, it's less than, but not including, so no. Are there any solutions in quadrant 1? Yeah, this whole thing right here is quadrant 1, right? So yes. Solutions in quadrant 2. Up here, no, there never will be, so no. 3, yep, there's some 3 right here and a lot of 4, so these 2 are good. So I want you guys to finish doing the last 4 of these and seeing if you actually can get this riddle right. Why did the plum divorce the grape? And when you are good with that, you can talk to each other and get help from each other if you need to. Then you guys will be ready to do the next checkpoint, which I think is checkpoint number 5 for you to actually look at graphing inequalities. All right, have fun.